Today, I'm going to show you how to use a new model inside ComfyUI called JoyAI Image Edit. This is actually two models developed by JD. One is specifically for single image editing, and the other is specifically for multi-image reference generation. At the same time, I'll also give you an optimized workflow that thoroughly solves the pixel alignment problem in single image editing. Let's look at this example below. This is also a vertical image. We directly edit it, which means changing the outfit because of the resolution issue. These two images are actually not aligned. To make it easier to see, I added a white border on the right side. You'll notice that after we regenerate the image, the white border disappears. But after using our optimized workflow, you'll see that the overall pixels are fully aligned, and the white border on the right is still there. As I just mentioned, JoyAI Image Edit is divided into two models, single and plus. It has two sets of diffusion models and text encoders, and these two sets must be paired correctly. But they share the WAN 2.1 VAE. In this video, we use a new optimized version, which is an int8 convert version. Also, pay attention. If you want to use the extended nodes we just mentioned, you must update your ComfyUI to the latest version. For easier demonstration, I also built the workflow on Running Hub. In the ComfyUI space, Running Hub is a very solid online workflow platform because whenever a new model or new extension appears, it follows up right away. Running Hub also provides an online communication platform for ComfyUI creators, where you can find a lot of creative inspiration and example workflows. Next, let's first look at the simplest single image editing workflow. It sends our reference image and prompt together into a dedicated multimodal encoding node. The final canvas is determined by FlyByEmpty's D3 latent image. Pay attention here. In this workflow, the latent can have a different aspect ratio from the original image. At that point, the model may reconstruct the overall composition. Because this workflow is for image editing, we need to remember four things when writing prompts. First, specify the object you want to modify. Second, clearly describe the target result after modification. Third, explain as much as possible what must be preserved. Fourth, clearly define the boundary of the edit. For example, if we are changing clothes, we can first write what clothing to change into, then describe the material and structure of that clothing. Finally, we lock the face, hairstyle, and pose so they stay unchanged. Then add one final sentence, only replace the clothing. A prompt like this is much more meaningful for the model. Next, let's do some basic tests. For these tests, I'll try to make them a little more interesting. The first one is removing a person, but pay attention. This is not just a simple person removal. In the original image, the person blocks a regular tiled wall. There is also a large shadow on the floor. This makes it very interesting. First, the background has a tiled wall made of red and blue diamond pattern, which is not easy to handle when removing a person. Also, you'll notice that the person casts shadows on both the tiled wall and the floor. So our prompt cannot just say remove the person. I need to explicitly say to remove the body, clothing, shoes, hair, and shadows. Then I need to ask it to restore the red and blue diamond pattern and keep the tile seams and the wall floor boundary continuous. What is the key point here? When removing an object, you also need to remove related elements. And after removal, you need to tell the model what the final state should look like. Next, let's look at a very interesting example material replacement here. We have a lamp. Its material is amber resin. Now I want to change it into translucent jade, but I want to lock the overall silhouette, which is a mushroom-like shape. Let's look at the overall result. The consistency is also very good. Apart from changes in the overall appearance and material texture, we can see that the bulb, switch, and some details remain consistent with the original image. The next example is also a typical use case. We need to move an object here. We have a teapot and a teacup. Now I want to move the teapot to a new position. To make that position clearer, we use a red box to mark it. So the core editing sentence becomes move this teapot to the position inside the red box and remove the red border in the final image. You'll notice that the overall movement result is very good. But pay attention, the size of the teapot changes slightly. If you care a lot about the size, you can emphasize in the prompt that the edited object's proportion or size should remain the same as before the edit. Next, let's look at one of the strongest abilities of the single model. We call it new viewpoints. Here we have a vintage camera. We will rotate the whole camera angle and generate views from 8 directions. At the same time, we need to lock the camera body material, lens, strap, buttons, background, and camera distance. When switching the angle, you only need to slightly modify the prompt. For the 8 directions, the generated results are almost all fine. But pay attention, the right side view has a small surprise. It generates 2 red buttons. Next, let's look at a relatively complex scene. This is a greenhouse library scene. In the prompt, we can use yaw, pitch, and zoom. You can understand these as horizontal angle offset, vertical angle offset, and zoom. Then we need to add one more sentence. Keep the whole 3D scene consistent. You'll notice that the changes in upward and downward angle are quite clear, but for left and right, it feels more like recomposition. Things like the stairs, pool, and character position may change. In one group, the character is even cropped out, so the single model is very strong at changing viewpoints, but sometimes its consistency can have issues. Next, let's look at whether this single workflow has any problems. Here is an image. The original image is 736 by 1104. I deliberately added a white border on its right side. In the official workflow, the empty latent resolution is 1024 by 1024. So after direct sampling, it generates a square image. You'll notice that the entire character and edge positions are redistributed. This is what we mean by pixel misalignment. Some people may ask, can I manually change the resolution? Yes, you can, because the model itself has reconstruction ability. Changing it to any resolution should basically work. For example, I can change it to 768 by 1280. Then you'll see it becomes an image like this, but it still does not align with the original image. Very clearly, the image becomes narrower, and the white border disappears. If we change it to 1088 by 1920, more of the body appears, but the pixels still do not align. Now let's look at how to keep the pixels aligned as much as possible. First, let's look at the first method, which is the simplest, preserving the original aspect ratio. Our method is to scale the longest side to 1024, and then let the empty latent use the real width and height after scaling. This way, after scaling, this image becomes roughly 680. 2 by 1024. It is still a vertical image, not the 1024 square image we saw earlier. But pay attention, this is not fully aligned. The white border on the right clearly still disappears. If you want full alignment or strict alignment, then I recommend using the method below. First, we do a proportional resize. For the resize mode, we use padding. We pad it to 1024 by 1024. Then the empty latent is also 1024 by 1024. After generation is finished. However many pixels we padded earlier, we crop those pixels off precisely afterward. This lets the model work inside a familiar square canvas, while also restoring the original vertical boundary. Can you see the white border on the far right? Its position is aligned with the original image again. You'll also notice that the character is not forcibly stretched. This is the strict correspondence method I'm talking about. Next, let's talk about plus. The examples we can use are basically the common ones everyone knows. So here I'll focus on a few issues that are easy to run into. As we mentioned earlier, the main difference between plus and single is that the encoding node can connect multiple reference images. The prompt must first explain the responsibility of each image. For example, image 1 provides the character, image 2 provides the clothing, and image 3 provides the prop. Now let's look at a few cases. In this case, we have 3 images, a character, a background, and a folding fan. One is used as the character, one is the environment, and one is the prop. Also, pay attention that their resolutions are different. Some are vertical images, some are horizontal images, and some are square images. We can write a prompt that combines these 3 elements into the final image. But pay attention. The character seems a little stretched. The body and clothing feel like they have been recomposed a bit. So I recommend using the same resolution as much as possible when using the plus version. That usually works better. There is another thing everyone needs to pay attention to, which is how you provide the reference images. The key is the character and the background. I recommend that when providing reference images, you put the character and background into the same main image from the beginning. This way, the main image is responsible for identity, pose, camera angle, space, and lighting. If we have a second image, it can be responsible for clothing. The third image can be responsible for props. In plain terms, I do not recommend separating the character and background. Otherwise, it is very easy to get that pasted on texture. Prompt writing also has some rules. For example, we say only change the clothing, let the character's left hand hold the prop, and keep the face, standing position, composition, and architectural structure from the main image unchanged. In the result, you'll notice that the relationship between the character and the overall environment is relatively stable. The shawl jacket, diagonal waist area, pleated skirt, and bronze trim all enter the image. The brass frame, transparent shell, and amber droplets of the dewdrop lamp are also fully preserved. Now, let's come back to these two models. My suggestion is, if you are working with a single image, use single as much as possible. Some people may say, I'll just use plus and only upload one image. Let me give you a simple example. For the 8-angle camera view we mentioned earlier, single can do it, but plus may not be able to, because plus focuses on multi-image reference, not single image editing.